All right.
Okay, thanks everyone for joining and welcome to the penultimate session of the DB2 stream of the GSE UK 2023 virtual conference. And what a conference it's been. We've had some fantastic sessions up until now. So I hope you have brought your bathers with you because Tori from the Washington System Center is going to take us for a dip in the buffer pools. So over to you.
Okay, thank you, Marcus. Well, hello, everybody. I am so excited to be here to present on DB2 for ZOS 101, buffer pools and group buffer pools. And again, my name is Tori Felt, and I currently work as a DB2 specialist or DB2 for ZOS specialist in the Washington System Center in the United States. And I have been working in this area for a little bit now, so I'm excited to present on what I've been learning about buffer pools and group buffer pools. And also I wanted to mention that Mark Rader is here with me today. So if people have questions, you can, I don't know, if you can definitely put them in the chat, and Mark will be here to help me monitor the chat and make sure that if anyone has questions, they're getting taken care of. And I will stop sharing my video now. All right, so let's get into it. Today's presentation really revolves around the basics of buffer pools and group buffer pools. And so it is meant to be a one-on-one session, so I will not be getting too deep into topics, but really just a high level to understand the basics of buffer pools and group buffer pools. So hopefully if you're more experienced, you will have a refresher in some way, or if you don't know anything about buffer pools or group buffer pools, hopefully you can learn something today. And the agenda I want to go over is starting off with what is a DB2 buffer pool. I will go into how buffer pools are used, why we use buffer pools, and then I will discuss some details, thresholds, and attributes of buffer pools, and then next go into group buffer pools and briefly discuss data sharing with group buffer pools. And then lastly, I will discuss how group buffer pools are used, and then what you could maybe expect if there were to be a follow-up presentation from this. What is a DB2 buffer pool? The overall idea is that a buffer pool contains the data that an application needs to access. A buffer pool is an area of virtual storage in which DB2 caches pages of tables or indexes and here into the buffer pool. So buffer pools are used to cache data in memory in a way that can be reused by the same or other applications. So essentially it is caching data into a buffer pool. And one thing to note is that every DB2 database object must be assigned to a buffer pool. More information about buffer pools. So a little bit of architecture here. Buffer pools reside in the DB2 database service address space called DBM1, as you see here in the picture. DB2 buffer pools are defined during DB2 installation, but they can be altered using the alter buffer pool command, which I will mention later on. So they can be altered later on, but they are defined and allocated during installation. And then I wanted to mention here what a buffer manager is. So it's really just a component of the DBM1 address space that's responsible for managing the buffer pools. And you'll see the term buffer manager as we go along. So I just wanted to mention that here. So we know what a buffer pool is, but why do we use buffer pools? Well, the main reason is that when we use buffer pools, it minimizes the IO activity to disk. So the main picture here is that if the entries are in the buffer pool, the search time reduces when searching for the data. So DB2 can retrieve a page of data from a buffer pool, in this case, our bunny rabbit, because they are very fast, faster than it can from disk, in this case, a turtle, which can be very, very slow. So when a data is already in a buffer, an application program avoids the delay of waiting for DB2 to retrieve the data from disk. And overall, this reduces CPU cycles and IO wait time. So that is the main idea of why we use buffer pools. Going into how we actually use buffer pools. So relating to my previous slide regarding how we want to retrieve the data from the buffer pools. Well, the buffer manager can do two kinds of IOs to retrieve those data pages, synchronous and asynchronous. With synchronous IOs, the data does not get into the buffer pool ahead of time. So really the application will wait for the buffer pool, wait to fill up the buffer pool as the pages are getting retrieved. So with synchronous IOs, DB2, say it needs a page, but it has to go wandering to get it. It starts an IO, and this is all happening while an application is waiting. But as opposed to asynchronous IOs, and this is when the data is in the buffer pool before it is actually needed. And with asynchronous IOs, we have something called prefetch. Prefetch is when overall DB2 will anticipate that an application process is going to want to look at pages that an application is bringing in. So in this case, the application isn't waiting as it would be in synchronous IO. So the data is getting into memory before it is actually needed. And there are three types of prefetch: sequential, dynamic, and list. Sequential prefetch determines in advance that a set of data pages is about to be used as part of an access path. DB2 can read the set of pages for sequential just with a single IO operation. And then next, dynamic prefetched is used when DB2 identifies a pattern, and this can be more robust and more of a flexible method. So if you think about dynamic, it's the idea of that DB2 can basically grab a bunch of pages, hoping to get these pages into the buffer pool before the application asks for them, and it can identify patterns such as getting every 10th page, for example, and then using this pattern later on. And then list prefetch is when DB2 reads a set of data pages based on a sorted list of record identifiers. So some of you may be familiar with the term record identifiers, but primarily we are taking these identifiers that we might have gotten from some sort of matching index scan, but we're really just collecting a set of these record identifiers and sorting them to be prefetched in a specific order. So those are the three ways that we can prefetch pages using asynchronous IO. So we talked about how we retrieve pages. Well, what actually happens once a page is retrieved? Once DB2 retrieves a page using really any of the methods I just discussed, what happens next? So the buffer manager, as we see here, will go ahead and place the page that has been received or retrieved into the buffer pool that is associated with the DB2 object that is being accessed. So the page comes into the buffer pool, DB2 can do what it needs to do with it, and the page can stay there until DB2 really needs to get rid of it to make room for another page. And I will get into that process in a little bit. Once the page is retrieved, it's now sitting in the buffer pool, and that page can either be in use, updated, or available. So if a page is in use, it is currently being read or updated, but to maintain data consistency, the DB2 or the buffer manager may only allow one agent to be updating a given page in a buffer pool at one time. But if a page is being read, they can allow multiple agents simultaneously. So if it's updated, it's one agent. If it's being read, it can be multiple agents. And then updated pages are pages that contain changed data, but those pages haven't yet been written out to disk. And then lastly, if we have available pages, as we see here, page 5 and 6 are now available, that means they are ready for use. So if an incoming page of data were to come in and need to make room, these pages could be available and the new pages could take their spot. Okay, some buffer pool page updates. So while a page is in the buffer pool, there are 4 main SQL statements that can change the data. Insert, update, delete, and merge. And there are more as well. And I won't get into too much detail here, but I wanted to just highlight these 4 statements to show that when data in the buffer, changes, that data must eventually be written back to disk. So because DB2 doesn't need to write the data to disk right away, that data can be in the buffer pool for other uses, and it can be getting updated or any of these really statements. But eventually the data will be written back to disk to make space for another page. All right, so I want to go through an example here of what happens once pages are retrieved, they're in the buffer pool. What happens if new pages need to come in? So an example here with page stealing on the left, we see a buffer pool with 6 pages in it. However, page 7 and page 8 show up. They're demanding to be let into the buffer pool. They need room. They need to be let in. Well, here in the same buffer pool, we see that page 4, 5, and 6 are actually available. They're ready for use. But how do we determine which page between these 3? How do we determine where page 7 and page 8 are going to go? For this example, we are choosing to use the least recently used method. So pages 4, 5, and 6 are all available, but based on this method, pages 5 and 6 have been least recently used and used the least amount of times. So pages 7 and 8 can take their spot. Well, now pages 5 and 6 can be written out to disk. And an example, a real life example that kind of makes sense when I want to think about it is if you think of a library, if the library is currently full, there's books everywhere, there's no room on the shelves, but an author just published 2 new books that really need to get in the library. They want to be on the shelves. So based on if we're using the least recently used method, some of the books in the library haven't been used or read in years. So these two new books can take their spot, sending those least recently used books to a different place. So we just saw an example of how page stealing works, but let's talk about what these terms mean. So when DB2 must remove a page from the buffer pool to make room for a new page, this is the whole idea of page stealing. So once a page is available, it can be stolen by a new page, and we have 3 ways of deciding which available page we want to steal. Least recently used, first in, first out, and none. Least recently used ensures that the most frequently accessed pages are always in the buffer pool. It can replace the others that are not getting as frequently accessed. First in, first out removes the oldest pages in the buffer pool, no matter how frequently they are being used. And then none is used when DB2 preloads the pages into the buffer pool when an object was opened, and it really tries to keep all the pages for an object resident in the buffer pool while the object is open. So those are the 3 page stealing algorithms. Okay, so now we've gone over what is a buffer pool, why do we use buffer pools, and how do we use buffer pools. Let's get into some more details and thresholds of buffer pools. Some buffer pool configuration. DB2 allows up to 80 buffer pools and up to 4 different buffer sizes or page size. And the maximum amount of buffer pool space is 16 terabytes. And just to note here that ZOS allows 4 terabytes of real storage. The size of the pages is controlled by the buffer pool that is assigned to the table space. And the buffer pool size can really affect performance. So the size is critical to the overall performance of the buffer pools. And as I mentioned before, you specify the buffer pools during DB2 installation, but can alter them using alter buffer pool command, which I will touch on in a little bit. Here is a chart showing the different buffer pools with the number of pools available as well as the size of the buffer pool. So really you can specify that DB2 uses up to 50 buffer pools that contain 4K pools, or you can also specify up to 10 buffer pools each that contain 8, 16, or 32K pools. So the term page fix, it specifies whether the buffer pool is fixed in real storage when it is used. So page buffers are fixed and unfixed in real storage across each IO and buffer pool operation. So if you don't say page fix yes, every time DB2 uses IO, it must fix that page. But if you long-term page fix, you don't issue page fix for each time for each read and write that you do with buffer pools. So ultimately, this will save CPU as opposed to fixing a page every time it does an IO. So the overall idea is that page fixing is beneficial when there is significant, unavoidable IO. Going into a little bit about frame size here, possible values are 2 gig, 1 meg, or 4K. And if frame size is 1 meg and page fix is no, DB2 uses 4K frames. The frame size can be changed to 2 only if that 2 gigabyte of real memory is available. And 2 gigabyte of buffer storage must also be available. If you use the alter buffer pool command, with the frame size option to modify the frame size for a buffer pool. One thing to note is that the change is pending. So the buffer pool becomes fixed only at the next allocation. And that is something that can get a little bit deeper in a follow-up session. DB2 buffer pool write activity. After a page is updated by a DB2 process, it's eventually written back to disk. And writes are triggered by DB2, and DB2 uses deferred writes to optimize IO processing. So deferred writes are triggered by either DB2 checkpoint processing, or when certain buffer pool thresholds occur, such as our horizontal and vertical deferred write queue threshold. And horizontal is how full of unavailable pages, as opposed to how full of unavailable pages for a page set. And I'll get more into detail on this in the next slide. But DB2 checkpoint can trigger synchronous writes. And what this checkpoint process really is, so if a changed page hasn't been externalized in 2 checkpoints, DB2 will then force it out synchronously. How do you create or change a buffer pool? So we talked about a lot to do with the sizing and some of our thresholds, but these are the these are the thresholds that actually determine all of these different attributes and sizes. So alter buffer pool really is the command to change the size. And as I mentioned, they're allocated at installation, but can be altered if needed. And then VP size defines the size of the buffer pool in pages. Page steal, as discussed previously, is our page stealing method. And you can define least recently used, first in, first out, or none. And then DWQT, which is the deferred write queue threshold. It's the percentage of the virtual buffer pool pages that can be occupied by unavailable pages. So if this threshold is reached, then this is when DB2 will schedule asynchronous writes to reduce the number of unavailable pages. And then next, the VDWQT, which is horizontal deferred write queue threshold. It defines virtual buffer pool pages that can be occupied by updated pages. So really the difference here is that the percentage of unavailable pages for our deferred writes versus the unavailable page sets for our vertical deferred writes. Continuing on for how do you create or change a buffer pool. As mentioned before, page fix indicates if pages are fixed in real storage when initially used. And really should use page fix if there is sufficient real storage available to support the fixed pools. And frame size determines the size of the frames for the buffer pools. And there are other attributes and thresholds as well that may be discussed in a future course, but for now, I just wanted to highlight some of those main ones here. All right. And maybe I can see the chat, but I can't see it right now. Mark, how are we doing? Are there any questions that have come up?
There's one question that came up and I'm in the middle of answering it. The question was, if frame size is equal to 2 gig and you have a buffer pool defined at 2500 meg, so a little over 2 gig, does DB2 allocate 2 2 gigabyte pages or 1 2 gigabyte page and the remainder is 1 meg? And so the simple answer is, if you've defined a size of the buffer pool greater than 2 gig, you'll get one 2 gig frame, and then the remainder will be 1 meg frames. But the way the question was asked included the word page, and DB2 is still going to use 4K, 8K, 16, or 32K pages. It's just a matter of how many of those pages will fit into the frame, right? So if it's a buffer pool 8K0 that you defined in a 2 gig frame size, then it'll be 8K pages, filling up that 2 gig frame.
Okay.
And there's
Alright.
another one that showed up. Go ahead and continue. I'll see if I can figure out this one and
Okay. All right, thank
respond to
you.
it.
Okay, so we just went through some details on buffer pools, but what are group buffer pools? Group buffer pools are used in parallel sysplex data sharing, really to coordinate flow of data between multiple subsystems. So within our parallel sysplex, we have resources known as coupling facilities, and these are essentially shared memory devices. But within a coupling facility, you can find several structures, and one of these structures will be the group buffer pools. So the goal here is to share information of the buffer pools using group buffer pools. And I'll get into a little bit more detail soon. So data sharing is a very deep topic, and Mark did a whole presentation on it this week, but just to highlight some important overall details here. Data sharing is a collection of one or more DB2 subsystems that share data. So it enables multiple subsystems to share really concurrent read or write access to a single database. So in simple terms, DB2 subsystems that access shared DB2 data must belong to a data sharing group. And then a subsystem that belongs to this data sharing group is called a member of that group. And then to note here that each member can belong to just one data sharing group. So now we know what a group buffer pool is and just the basics of data sharing, but how do group buffer pools actually work? Well, what if you have two DB2 subsystems that have the same data in their buffer pools? Here we have subsystem 1 and subsystem 2, which have the same data for buffer pool 0 and buffer pool 1. Well, in this case, group buffer pools 0 and 1 can come in and really serve as the intermediary of these subsystems for the buffer pools. So the purpose is to track when both members have a copy of updated pages. So if we think of an example, let's say Kevin is in buffer pool 0 on subsystem 1, and he updates one of these pages. Well, the other members in subsystem 2 that he just updated are now out of date. So group buffer pool 0 will need to make sure that it has the updated page that Kevin updated for the next time that this page has to be referenced. And one thing to note is that there is one group buffer pool for all buffer pools of the same name that are actively sharing data. Going into DB2 group buffer pool details, directory entries manage coherency by tracking interest in table or index pages for any DB2 member. So pages of any table space or index space that is actively shared, meaning there's at least one reader and one writer, they must have a directory entry. So a directory entry, it only tracks a single page, but it has a pointer to the buffer where the page resides. And then next we have data elements. Data elements are the cached copies of the pages that are changed by any member in the group. And data elements do represent the most current state of the page. Once we have changed pages in the group buffer pool, they eventually need to be externalized to disk. And that process is called cast out. So over time, we will write the pages out to disk, and that's really the whole idea of casting out the data. And then another thing I wanted to note here is that with group buffer pools, duplexing group buffer pools is strongly recommended. And for an example with duplexing group buffer pools, it's the idea that if, for example, say Mark has a very busy DB2, well, maybe he updates page 11 in his DB2 and it gets written to the group buffer pool, but then it can be stolen within his local buffer on that page 11 that he updated. So the only copy of the new version might be in the group buffer pool. So we need to protect this. And this is why we duplex the group buffer pools. So if Mark changes page 11, it will be written to the secondary subsystem. And basically, if something were to happen, now we have the group buffer pools duplexed. Okay. Some information here on managing coherency of group buffer pools. The group buffer pools contain information that's really necessary for maintaining cache coherency. And cross-invalidation is when a member needs a page of data. It finds it in the buffer pool, and it tests to see if the buffer contents are still valid. So when a changed page is written to the group buffer pool, all members that have this page in their buffer pools are notified that a page has been invalidated. And then group buffer pool cache determines whether the group buffer pool is used for caching data and cross-invalidation, or if it's just for cross-invalidation. And then class cast out changes the threshold at which data in the class cast out queue is cast out to disk. And lastly, our group buffer pool cast out threshold changes the threshold at which the data in the group buffer pool is cast out to disk. So for example, here, if this threshold were set to 55, then it casts out data if the number of pages in that group buffer pool equals 55%. And those are just some examples of thresholds and attributes of group buffer pools, and there are many more which could be discussed in a future session. So if there were to be a follow-up presentation on this, I did not go into too deep of configuring, monitoring, or tuning buffer pools and group buffer pools, but that would be a logical next steps to discuss buffer pools and group buffer pools. And that concludes this presentation on buffer pools and group buffer pools. And of course, feedback is always appreciated. And my email here is victoria.felt@ibm.com. If you have any future questions. And thank you all so much for listening. And I hope you have a great rest of your day. and weekend, as it is almost Friday.
Well, thank you very much, Tori. That was a great presentation. Really clear, comprehensive, and yeah, well done. So thank you very much. It's been a pleasure to host you, and I hope Anna gets better soon. And thanks also to Mark for facilitating this, and to Keziah also for presenting. We look forward to hearing Mark in just under an hour, I believe, because we finished it a little early.
Yes, definitely finished earlier than expected, so people can go work on other things now.
So you can get back to your real jobs for the for the next say 45 minutes. So at 3:30 GMT, we have Mark Rader on another DB2 for ZOS 101 session, DB2 and WLM. So if you want to know all about Workload Manager and how DB2 uses it, please join us at 3:30. Following that, there's a 30-minute break and our final keynote. So
Marcus, I think I have Andreas's answer. The question was about how do we get all the change pages pushed out of the buffer pool? And he had 3 different options: archive, log mode, quiesce, and 2 variations of the set log command. And as far as I can determine, none of those will force externalization of changed pages. Each of them is about forcing the log buffer. So DB2 will force the log buffers out, you know, depending on which one you do. And in the case of
well, I'm sure Mark will, if he's not back in a few seconds, he will continue answering the question when he presents. So yeah, it just falls to me to wrap this session up. So once again, thanks, Tori. Thanks everybody for joining, and we'll see you at 3:30.
All right, thank you very much. Thank you, everyone.